Welcome. We would like to keep the advantages of a transmission measurement to see the sample and full depth. Where there is a decrease of particle concentration, the X-ray transmission will increase. And after 3 seconds, we already get the information. Here we have a slight deviation in the values, which is telling us being cured and measured as a solid from about 20 millimeters up to the filling height of X-ray transmission. That means there is an increase of particle concentration. That is an information you will obtain only by X-ray. The naked eye fails here, and the corresponding near-infrared profiles also do not discriminate these changes. Here we have one of the first advantages by combining X-radiation and independent accelerated separation. The big advantage of X-radiation that for this wood preservative we understand it is not sediment of identical particle concentration, but there's a concentration gradient. We also see the concentration gradient of the supernatant and the turbid phase top of the sediment. The region of interest applied in this example is 10 to 25 millimeters. If there's a small difference, we can say it's a homogeneous sample. If there's a big difference, we can say it's an inhomogeneous sample. Information on particle dispersibility, on the homogeneity of samples. This is followed by the separation kinetics, access to stability information, later on information on the separated phases, and last but not least, you have always the chance to put customer's point of view into the discussion and into the sample understanding. Dispersibility, real-time stability behavior, there's an original concentration. Last but not least, there are applications reported where we have particles in a solid matrix analyzed by Lumioda X-ray. So it is a very, very powerful. I'd like to thank all our international guests joining this webinar. See you next time.